Alright. Got it?
I still can't see it.
Well, you see that.
I can't see him either.
Horizontal asymptotes. How do we find horizontal asymptotes? So if I have a graph, let's start there. If I have a graph, okay. So we're going to back up a little bit. Sorry, Stephen. If I have a graph, where do I look for horizontal asymptotes? At the ends, right? And you're like, I'm looking across, but I'm looking. So if this is a horizontal asymptote, could I cross that horizontal asymptote in here? I can, right? Hey, pal. How you doing? Good. So if I have a horizontal asymptote, I can cross as much as I want in there, but it'll level off as I go that way. It'll level off as I go that way. So if I want to know if there's a horizontal asymptote, what x value or values am I interested in? Positive and negative infinity. I don't care about the x value as x approaches I don't care about as x approaches 4 or 10 or 100. I care about as it goes to infinity. So if my x value goes to infinity, and I read off and the y value is approaching 3, let's say, that's a horizontal asymptote. If I look as I go to negative infinity, and it approaches whatever, that's a horizontal asymptote. So how do we find from an equation is we look at the limit, remember limit is just y values, as x approaches positive or negative infinity. So those are the same thing. If I ask you the limit as x approaches infinity, or I ask you what's the horizontal asymptote, you might answer them slightly differently. Because one you'd say 3 and one you'd say y equals 3, but they're essentially the same question. I'm trying to get the same information out of it. So, I can phrase it two ways. So let's say the limit as x approaches infinity of 4x squared minus 3 over x to the third minus 5x plus 7. Just as an example. So I'll do a couple examples and then I'll make like a general set of rules that we can apply to any problem. Hopefully any problem. Well, what I'm going to, first of all, if I'm looking at infinity, like infinity is a gigantic number. I mean, 10 billion isn't even close to infinity because infinity is just like the biggest thing you can even think of. So you got some gigantic number, you square it, multiply it by 4. Is subtracting 3 going to do anything? It doesn't matter at that point because you're at such a big number, subtracting 3 is irrelevant. The same thing with this minus 5x and plus 7. If I take 100 Google, which is 100 zeros, cube it, and then subtract 5 times that and add 7, this part doesn't do anything. It doesn't do anything relevant. So all you care about is the highest power on top and the highest power on the bottom. none of the rest of it matters, because if I have like 8 gajillion, trillion, billion, whatever, minus 2, like, that doesn't really do anything. So let's look at that. Well, I can reduce that a little bit, right? Isn't that just the same as 4 over x? Because I can take an x squared out of the top and the bottom. And now imagine plugging a gigantic number into here. So let's start small. What's 4 divided by 100?
0.04.
So the rest of you just not want to say it, or was that like a hard question?
Everybody said it really quietly. Right?
Okay. What's 4 divided by 1,000?
0.
What's 4 divided by 10,000? So as I let this number on the bottom get bigger and bigger and bigger, what is this number going to get closer and closer and closer to, but it will never actually be? 0. So the answer to this question would be 0. Or you could say there's a horizontal asymptote. Be careful how you abbreviate horizontal. At y equals 0. Or you could say the limit as x approaches infinity is equal to 0. Those are the same statement, just 2 different ways. Right. Let's look at a different example. Let's say, can I move that one? Are we good? Is that might still right? Let's say find horizontal asymptotes, and I give you this equation: y equals 3x to the third minus 4x over 5x to the third plus 6. So you got to keep in mind horizontal asymptotes and limits at the extreme x values are the same thing. So if I want horizontal asymptotes, this is exactly the same as if I told you find the limit as x approaches infinity of that equation. You can think about it either way you want to. The same concept. Let's start like crossing stuff out again. Does this minus 4x make a difference? No. Does adding 6 to the biggest number you can think of make a difference? No. Reduce that. What do you get? 3/5. The x's go away. That's your limit. Your horizontal asymptote would be at y equals 3/5. Or your limit is 3/5. That's the second scenario. What was different about the second scenario compared to the first scenario?
X is canceled out.
The powers were the same in this one, right? And where was the highest power in the first example? Bottom. So the third scenario would be, so what's left? Highest power is on top. So let's say x to the third minus 4 over 2x plus 7. So minus 4 doesn't do anything, plus 7 doesn't do anything. Reduce x to the third over 2x. What do I get? X squared over 2. So I'm going to take the biggest number I can possibly think of, square it, which makes it way bigger than I even thought of in the first place. And then dividing by 2 won't do anything either. Like that's, at that point, it's irrelevant. So basically, I'm asking you what's infinity squared. It's still infinity. Or think about it this way: if I graphed x squared over 2, it looks like that. As the x value gets bigger and bigger, like as I go more and more to the right, what's happening to the y value? It's going up forever, right? It's getting bigger and bigger and bigger also. Right? So in this case, this would be your limit, and you would say there is no horizontal asymptote. Because it doesn't level off, it just goes up forever. Or it could go down forever also. So there's your 3 examples, that's your 3 different possible scenarios. So the rules for the highest power If the highest power is on the bottom, where's your horizontal asymptote? 0 is not specific enough.
Constantly approaching it.
And y equals 0. It's a horizontal line, so you got to meet the equation of the line, which is y equals 0. Or you could say the limit as x approaches infinity equals 0. Those are the same exact statement. If the highest power is tied, where's your horizontal asymptote? The coefficients in front of the highest power. It would be the horizontal asymptote at the coefficients of the highest power. Which I think that makes sense. That's like the 3/5 here. So the highest powers were x to the third, x to the third. They were tied, so then 3/5 becomes the horizontal asymptote. Because what happens to those highest powers that are tied? Because they just cancel. Or limit as x approaches infinity equals coefficients of highest power. So what's left is if the highest power is on top, that would be no horizontal asymptote. And your limit as x approaches infinity would either be positive or negative infinity, depending on whether we have a positive or negative number for our y value, which we'll go through how to check that. So those are your three scenarios. One thing to keep in mind is you always simplify before comparing. For example, if I gave you that, if I go too fast, I feel like I'm going fast.
Is that 4x
Okay.
squared?
That's supposed to be 4x squared, yeah.
Well, hard to read.
So you simplify before you compare. And I don't know how to take the square root of 4x squared minus 9. I don't know what it is. It's not 2x minus 3. Because if you squared 2x minus 3, what's a binomial squared give you? A trinomial, so it doesn't work going backwards the same way. I don't need to know the exact square root. I just need to know the square root of the highest power. So I could almost just cross this off and be like, never mind, this is just the square root of 4x squared over 3x. What's the square root of 4x squared?
2x.
2x over 3x. So what's the limit? 2/3. So I simplify the highest power portion of it, and then I compare from there.
Just seems so wrong.
It seems wrong.
Why?
Why?
No, like I know it's right, but like it just seems like you're.
Feels so wrong, but it feels so right.
Just chop up everything up.
Like, but you get why though, right?
Yeah.
Like if I have some gigantic number minus
Like I
9
just wish
is
you
like,
could do that to after what you just saw me.
yes.
Yeah.
Yeah.
So, what if you had a limit like that, or a limit equation like that? But then there was another piece to the highest power on the outside. So, like, we simplified it down to the square root of 4x squared, and then outside the square root, we had like another 2x squared.
Let's do that. Let's say this. Say give me that. graduated there with from a basic example to a pretty tough one. I'm only going to simplify the highest power portion of it. That's all I care about. So this minus 8 doesn't mean anything to me, so I can basically just get rid of it. This is the part I think is harder. What is the square root of 3x to the 6th?
Something x cubed. It's like 1
X to the third, right? Because it's the exponent over the...
So there's a couple things going on here. One is you got to take the square root of the number. So the square root of 3, you just write it as the square root of 3. So if I were rewriting this, I'd say, okay, that's 2x times the square root of 3. The second part is, what's the square root of x to the 6th? Some people mess up and you want to take the square root of that power. That's not how powers work. What number is really out here? Like, what root is that?
So the 6 over 2.
And what you do is the 6 divided by that 2. So this would be x to the third. So, like, what's x to the third times x to the third? X to the 6, right? Like, that's y is the square root. That's how that works. So that would be my top. The bottom, I'm at 7x to the third. Where is my highest power? It's on the top, because really, what's my power of x on top?
4.
It's really 4, so this is really like 2 times the square root of 3 times x to the 4th over 7x to the 3rd.
So it just goes into infinity.
Yeah, and so you could kind of work a couple of ways from here. You could say, well, the highest power is on top, so I'm just going to go infinity. Or we could reduce it, which is better because then you can get a better idea of positive or negative. The highest power is on top. If the highest power is on top, your answer is going to be positive or negative infinity. At that point, do I give a crap about these coefficients?
No.
I do not, because all I worry about is whether it's positive or negative infinity. Cross those out. Reduce x to the 4th over x to the 3rd, what do you get? Get x. If I plug infinity into x, what do I get? Infinity. If the question were negative infinity, though, if I'm plugging negative infinity to x, what do I get? Negative infinity. So it could go either way depending on how the question was. But this, your limit would equal infinity, or there'd be no horizontal asymptote. So to answer your question, you would simplify the inside part first, like we did, and then multiply it by 2x on the outside. That's what you were talking about, right?
Yep.
Okay. Question on that guy? Let's say limit as x approaches negative infinity of 2x squared plus 3 times 4x minus 5 over 3x to the 3rd plus 1 times x plus 6. Try that.
Is x approach negative?
Yeah. Foiling the whole thing, kind of wasting your time. It's not wrong, but you only have to worry about what the highest power is going to be. So the rest of it doesn't make a difference, so you don't really have to foil it. All I care about is what's 2x squared times 4x? 8x cubed. What's 3x to the 3rd times x? 3x to the 4th. Where's my highest power? Bottom. So what's the limit? Where's the horizontal asymptote? Don't say 0. If you tell me on the test horizontal asymptote at 0, I'm marking it wrong. Just make sure you realize that at y equals 0. Question on out?
Wait, what is it?
Why? What?
When is our test?
Not like tomorrow. Not anytime.
What would the question be?
ask this question two ways. So, if this was the equation I decided to use, I can either say find horizontal asymptotes, in which case you would answer it by saying y equals 0. Or I could say find the limit as x approaches infinity, in which case you would just tell me 0. Good?
Mark it completely wrong if we accidentally put the wrong one.
No, I don't know. I mean, maybe half credit or something, but you'd lose points. Because the reason is on the AP test, it'd be multiple choice, and if you're choosing between 0 and y equals 0, and you choose the wrong one, you don't get half credit. You just get it wrong. So that's like why. That's my justification. Good? Questions? Alright, let me get you guys practicing on your own sheet instead of just watching me do it. That's coming like next.
Who wrote that on the board? Sid versus Skill. 21-17. 10-50. So that had to be someone in our class. That's great.
So work on this classwork. This is not like do it at home. You're doing this right now. I don't care if you work together or by yourself. I do care that you work. Work out the best question that you have, check the answers in the back, and let's just see where we're at. What?
I can just see the rules right and just write it down.
Are you asking if you have to show your work?
What it's
I don't care if you show your work. I care if you get the answer.
if it's infinity or negative infinity, do we write no limit or infinity or negative?
Right, infinity or negative infinity. Is that what you're asking? Look, if you show your work.
Yeah.
Yeah, you're right.
Yeah, it's negative infinity. What is that?
Hold on. What was your question?
If it's not fraction, power over 1 and
Your highest power is on top. It's over 1. So you put it over 0.
I mean, power technically.
Yeah.
So it's the power balance.
Right.
So
So the highest power is on top. Yeah. Yes. Oh yeah, that's what negation is, right? Yeah. What was your question, Lauren? No question.
I'm asking on the elevation.
If it's 0, it doesn't matter. If it's coefficients are tied, it doesn't matter. But if it's going to be positive or negative infinity, you have to worry about whether it's going to be positive or negative. So like that one, like this, it doesn't matter what I plug into it because it's just straight up 0.
Oh, I see. Yeah.
But this one that we did, like after we cancel everything, we're left with an X. Then it matters. You with me?
I'm confused.
All right, what number?
Well, I just don't, like, 2 and 4, like, I don't understand why it's positive and negative. I don't understand that tell.
Okay. So 2. This doesn't matter, right? And then if I like kind of reduce stuff, I'll have negative x over 2 for my answer. You see that? Now plug negative infinity in for x. And you actually end up with a positive infinity divided by 2, so that's why it's positive. Well,
Hey, Mr.
Davis.
Yeah.
Yeah. What number?
Why is number 7 what? Number 7 2.
So you got to take the
Oh,
square
take
root
the square root
of
of
4.
Yeah, I got it. I just read it.
Oh, you're good.